Every second, the internet moves more data than you could store in a lifetime. You use the internet every day, sending messages, watching videos, opening websites, and accessing apps instantly. Most people think the internet is invisible, wireless, or simply in the cloud. That's a misconception. Every tap on your screen triggers a massive physical system. Fiber-optic cables, routers, servers, and data centers coordinate globally, processing millions of requests every second. In this video, we will follow your data's journey from the moment you touch your phone, through local networks, internet backbones, undersea cables, and servers, all the way back to your device. By the end, you will understand the real mechanics behind every click, scroll, or message, and appreciate the engineering marvel we call the internet. Your device doesn't choose the path. It all begins with a simple action, touching your screen. Your finger activates a small electrical signal inside your device. The phone converts this into digital data, broken into small packets. Each packet contains the destination, the origin, and instructions for reassembly. Some packets may travel through different routes to reach the same destination. Even the smallest action, a text message, a video request, or a like, is processed as data packets. Your device does not choose the path. It only prepares the information and sends it to your router. In milliseconds, your device fragments, labels, and pushes data into your home network, starting a journey that will span local routers, ISPs, and global infrastructure. Local networks and routers. Once your data leaves your device, it enters your local network, typically through a home router. Routers are more than Wi-Fi access points. They act as traffic managers, deciding which path each data packet will take. If multiple devices are connected, routers prevent collisions, manage priorities, and optimize speed. They constantly check availability and reliability of different routes. Local switches, modems, and Wi-Fi signals handle internal routing, while your ISP takes control once data exits your network. Even small delays in a local network can ripple through the system, affecting speed and delivery times. Every decision your router makes ensures that your packets reach the wider internet efficiently, making it a critical first step in a complex global journey. ISPs, data centers, and the internet backbone. After leaving your local network, data enters your internet service provider, or ISP. ISPs operate extensive infrastructure, high-capacity routers, fiber-optic cables, and data exchange points. Your packets join millions of others, moving simultaneously through a web of interconnected networks. Data centers play a central role. Thousands of servers inside these facilities operate 24/7, running calculations, storing information, and coordinating traffic. High-end routers analyze real-time network conditions, redirecting packets to prevent congestion or delays. The internet is not one single network. It is thousands of independent networks cooperating seamlessly. Redundancy, backup systems, and advanced routing algorithms keep traffic moving reliably even during peak times or unexpected failures. Without this coordination, what seems instantaneous would grind to a halt. Undersea cables and global routing. To cross continents, most data travels not through satellites but undersea fiber-optic cables. These cables stretch thousands of kilometers across oceans, connecting continents and enabling international communication. Light pulses carry data at near-light speed, transmitting videos, emails, and messages instantly. Cables are engineered for durability, but environmental factors, storms, earthquakes, or accidental cuts, can cause temporary disruption. When this happens, alternative routes activate immediately. Redundant systems and multiple pathways allow the global network to remain operational even if a major cable fails. Your device's request may travel under the Atlantic, through Europe, and back again in fractions of a second, all while you perceive the experience as instantaneous. Servers, response, and return path. Finally, the data reaches its destination, a server. The server processes your request, retrieves the required information, and sends a response back, divided again into packets. These packets often do not take the same path back, instead choosing the fastest route available at that moment. Routers, switches, and ISPs guide each packet along the most efficient path. Data centers monitor traffic, automatically rerouting if congestion occurs. Once the packets arrive at your device, they are reassembled correctly. The video plays, the message appears, or the website loads. What feels instantaneous is the result of millions of precise calculations, routing decisions, and physical infrastructure working together at every second. The internet may feel simple and instantaneous, but in reality, it is one of the most complex systems humans have ever built. Every message you send, every video you watch, and every click you make depends on a massive, global physical network operating nonstop. Fiber optic cables stretch across continents and oceans, servers process and route data in milliseconds, and routers and undersea systems work together seamlessly to deliver information almost instantaneously. Understanding this hidden infrastructure allows us to truly appreciate the incredible engineering, planning, and technology behind something we often take for granted. Every time you browse, stream, or communicate online, you are witnessing the outcome of decades of innovation, collaboration, and precision. Now that you know how it really works, you can see why these systems are both powerful and fragile. In our next video, we will uncover another invisible network that impacts our daily lives. How clean water reaches millions of homes safely and reliably.